Yeah, or in other words, where should we put the wood? So I don't know if we've got any GISRUK regulars here in the room, your rooms, the chat rooms, whatever. But last year I went up to the frozen northern wastes of Newcastle, gave a talk about measuring the value of natural capital in UK farms and agricultural areas. Basically, can we measure the value that nature provides us? That work is now thankfully done. And one of the big takeaways we got from that is if you want to get more natural capital in an area, you need to plant lots of trees. Why? Because trees give us all sorts of benefits. They offer opportunity for recreation, they can give us timber, they can improve air quality, and quite importantly, they can sequester and store carbon dioxide from the air. Obviously, now we've got quite widespread recognition of the dangers posed by global climate change, and large-scale afforestation has been proposed as one potentially pretty important response to this. That's because obviously trees can store carbon in their biomass, it gets stored in the leaf litter and the soil and the forest floor. You can either just leave the tree standing, use it as a bit of a carbon store, or you can chop them down, use the timber in things like buildings, long-lasting applications which keep that carbon locked away for potentially hundreds of years. And so because of this, we've got all sorts of global schemes looking at trying to encourage afforestation across the world. Globally, we've got things like the UN's Paris Agreement. A couple of years ago, we had about 196 countries sign up to conserve and enhance carbon sinks like forests. We've got things like the Trillion Trees campaign, Team Trees, the Bond Challenge, which are all different schemes looking to try and afforest different areas of the world. But it's also becoming a big hot topic here in the UK as well. So the UK is actually the first major economy to make achieving carbon neutrality a law. We're looking to do that by about 2050. And our Committee on Climate Change has stated that as one of a range of measures to try and achieve this, we need to plant lots and lots of trees. But it's not only them saying this. We've also had a look through the literature, and we found about 14 different targets for forestation coming from different organisations like charities, government departments, learned societies, and some less reputable organisations. You can see down here the planting rate they want and the overall target they want us to achieve. And I've just put some comparisons down the right-hand side here. So these are pretty substantial numbers. So, we saw this and, right, so we want to plant all these trees. We now know from our earlier work, as well as carbon storage, they can also give us lots of other benefits. So we started working on a little project looking at, okay, if we're going to plant these trees, where should we put them to maximise for the provision of ecosystem services? Where can we put them that they can also offer, recreational opportunities and flood mitigation and, air quality improvements and whatnot. So we went and we got started with this and looked through the literature and all that, and just kind of an afterthought, really, we thought, well, okay, you can't plant on, buildings in urban areas, whatever, so we should probably just take those out of the equation. But then, okay, I've worked on farms quite a lot, it's like your ponds and lakes and rivers and all that. You can't really plant on those. You should probably take those out too. Oh, well, you can't plant on existing trees either. That's not going to work. There's a tree line as well. It might be important in Scotland, and well, it all kind of spiraled out of control a little bit. And what we ultimately discovered was that if we want to figure out where we should put these trees, we're going to have to first figure out where we could put them, in the first place. So we went, had a look through the literature and, looked through existing comparable studies, Forestry Commission guidance, stuff like that. And we actually found this big old list of reasons why you wouldn't be able to put a tree in a location. So along with all these, physical ones, which I was talking about before, you just literally can't plant a tree there. There's also environmental considerations. You don't want to plant on deep peat or bogs, for example, because that can actually release carbon dioxide, which is the opposite of what we want to do. It can also damage habitats there as well. Planting in protected areas, for example, like national parks, is pretty difficult because you have to get an environmental impact assessment, and agricultural land as well. Obviously we want to have some measure of food security, but also farmers are often quite reluctant to plant on good quality land. And there's actually, a report come out a couple of years ago that's saying because of competing land uses, we could be seeing a shortage of good agricultural land in this country. So, okay, might want to plant on that either. So we went, we gathered the data for these different layers. Obviously, as always, that's easier said than done. We had a couple of issues. Big ones probably around the agricultural land classification. So this is basically a map that shows the quality of agricultural land in different areas. So there is one available for England, but what we found is it's pretty old and it's got pretty coarse kind of attribute resolution to it. We couldn't really differentiate between the different qualities of farmland as much as we'd like to, but it's all that's available nationally. Northern Ireland, on the other hand, there's also a map available. Despite lots of pestering from us, we weren't able to get access to it, so we weren't able to use that. What we ended up doing was instead using existing arable land as a proxy. We identified that using the CH land cover map. And our idea was basically if land's being farmed currently, it's probably decent quality. We do, however, think that's probably going to be a bit of an underestimate, and that'll probably kind of jump out a little bit in the results. Similar for peat soils as well, we could use the British Geological Survey data to get the locations for that for GB and for a chunk of Northern Ireland as well, but we couldn't get it for the whole country. That being said, we also had a bog layer as well from the CH land cover map again, and that includes vegetation on deep peat. So we were still including it to some extent. We just use a really simple approach. We basically start off with the UK our base. We overlay the places where for various reasons you won't be able to plant. Look at the areas of those. If you take those away, what you're left with is areas which are unconstrained and which are therefore available for tree planting. So what I've got here is maps showing these different constraints to tree planting in the UK, shown in the red. What we found was what we are grouping together these kind of policy constraints cover by far the greatest area. So there's about 7 million hectares of protected areas in the UK. There's about 2.5 million of excellent and very good quality agricultural land. That's in the lighter red here. And a further 7.5 million of kind of good to moderate quality agricultural land as well. So these by far take up the most space and most expansive. As you can see, they do vary pretty substantially in terms of spatial distribution as well. So here in England, it's very much the agricultural land which is the biggest one, whereas in Scotland, about a third of the country's got some sort of protected designation in some form. So that's the biggest one up there. And it's the same for environmental constraints as well. You can see most of these are located in Scotland and up in northern England as well. So what does this all mean? So basically, if we consider all of the constraints I've been talking about here, if we talk about the physical ones, why you don't want to plant for environmental reasons, for policy reasons, all that, we take all those together into like one really restrictive scenario, we end up with this. So on the left here is a map showing the different constraints in the UK, and we're doing that using this kind of colour blending style symbology. So each of the 3 different category of constraint are assigned a primary colour down there in the bottom left. Where these overlap, an area might be trees in a protected area, for example. The colours overlap to produce the secondary colours, and where they all overlap, you get black. So that's where there's every category of constraint. So that's the constraints over on the left. Over on the right, it's a bit of a simplified view. That's basically, it's only showing where we can plant the trees. That's in green compared to with just the background, dark grey there. So essentially in this really restrictive scenario, what we found is there's about 4.7 million hectares of land left over. So this is enough to meet even the most ambitious planting target we were able to find from the literature, which is about 4 million hectares by 2100. Although obviously meeting that would mean that you'd have to plant in just about every one of those green pixels on the map. You wouldn't have very much flexibility to do it. That is the highest ambition. Now, if we look at a more moderate one, the Committee on Climate Change's kind of median ambition scenario, that is looking to plant about 2.5 million hectares. So you'd have to plant about half of that. And what I found quite interesting was how much of this available land is sort of in these kind of mountainous, remote sort of areas. You can see sort of it's often like the Cambrian Mountains, the Pennines. There's a bit, in the Central Belt in Scotland, but also a lot up north in the Highlands as well. So all this available space is in pretty remote areas. Well, that's a really restrictive scenario. If we relax this a bit, okay, agricultural land, the biggest constraint in England. What happens if we allow for planting on moderate quality land? We're still keeping out the highest quality, but we're not being quite so restrictive with it. Well, we end up with this, and what basically happens is we more than double the amount of space we've got. So there's now about 10.4 million hectares available for planting. And it kind of evens out the distribution quite a lot. There's now about 5 million in England and about 3 million in Scotland. So it's more evenly distributed across the UK. Well, okay, what happens if we then kind of swap it around? Now we prevent planting on agricultural lands again, but this time, okay, what happens if we plant within protected areas, if we plant within national parks, A and Bs, whatnot? Well, you kind of get something in the middle. You get about 7.9 hectares left over. So between the first one and the previous one. What I find quite interesting about this one as well is how much of this is up in the north, in Wales, compared to down south. So if we consider England, about 30% of northern England has potential for forestation to occur, compared to about 13% of the Midlands and about 16% down south. So, that could potentially be a bit of a problem because there are quite a few people down south. There's a lot of people there that will be missing out on the benefits that forestation can provide compared to up north with these green blobs. So, what do we get from this? What are the implications of this? Well, so as we've seen in these different scenarios, the distribution of this unconstrained land isn't even. It might be constrained up into the mountains in the first scenario, up around North England, Scotland in the previous one. And because we have to plant so much of this available land, there's not really flexibility to do it, either to put the trees in the most optimal locations to try and get most benefits from them, or to consider how easy or difficult it might be to turn an area of land into forest. You can't, you can, but it's difficult to just take an area, make the owner give it to you and then turn it into a forest. There's going to be considerations around that. That being said, obviously, other than the purely physical constraints, so the trees, the water, the rock, or whatever, the places where you just literally can't plant trees, these all could theoretically be flexible, which is what we've seen in the different scenarios we've run through. In the first scenario, about 80% of the UK is covered by one or more constraints, but over half of these are just purely policy ones, so agricultural land in protected areas. So there's no reason that we might decide, actually, it's probably going to be beneficial to give up a little bit of food security if it means that we can put trees next to this city or whatever to give them a recreational opportunity. There's going to be a lot of considerations and compromises that are going to be made when we're thinking about this sort of stuff. And obviously, we're coming at this from a very kind of top-down view. We're looking at these big national scale maps to test these national scale targets and goals. But this planting is going to have a really big impact upon local communities, and that's going to have to be considered, and it's something we're going to be looking at in the next stages of our work. If we have a think about what this planting is going to replace, what these graphs basically show is in each scenario which land is unconstrained and could therefore be planted upon. And you can see it's the sort of stuff you would typically see in typical British landscapes. You've got a lot of improved grassland, used for grazing and whatnot. Got kind of acid grassland, kind of also known as rough grasslands, which is a lot of sheep grazing, stuff like that. Some bits of kind of lower quality agricultural land. So it's sort of what you expect really, but it can be quite hard to kind of visualize what these numbers actually mean, 4.7 million hectares and all that. Well, okay, if we use an example, the Committing Climate Change Median Ambition scenario, which is the one we think the government's kind of currently working to. The aim of that is to get about 2.5 million hectares of woodlands by 2100. So to put that into perspective, that's equal to about 3.5 million football pitches. Not that I'm saying we should plant on all the football pitches. To put it in a slightly more useful perspective, that's equal to about 30,000 typical average size UK farms. Or, another way, that's about asking farmers in 120,000 farms to plant 25% of their land. So this is potentially going to be really disruptive, either seeing tens of thousands of farms be replaced with forestry, or hundreds of thousands of them being asked to change their business model pretty substantially. And when you get down to it, a lot of farmers are farmers because they like farming. There's actually a lot of literature on the subject about how difficult it is to convince a farmer to plant upon their land. You're not only asking them to change their farms, you're asking them to change their careers and really their whole identity. It can be difficult. You can offer grants and whatnot, but a lot of the literature says, it's not always just about money, it's about more than that. So we are potentially looking at a root and branch reform of our rural economy. In terms of landscapes as well, this is potentially going to have a big impact. Obviously, it's really difficult to quantify this, and it's actually really interesting listening to Labib's talk then. But there's rough kind of research saying that people like about 25 to 50% of their landscape to be trees in the UK. If you get more than that, then it starts to feel kind of enclosing, and it starts to take over the landscape, and actually people don't appreciate it. And obviously this is it's a really difficult thing to measure, so these are just kind of rough guides. But especially in places where there hasn't been forest before, and if this forestry is sort of commercial forestry, it's using non-native species, especially conifers here in the UK, then people can have a really negative perception of it. And this is coming up a lot in Ireland, where they're doing a similar push to get these their tree cover in the country up there, and they're actually getting quite a bit of resistance from local communities. And I think it's very much the case that we'll probably be seeing the same sort of thing here when we start putting these big plantations in. Right, so I've been mainly talking about this in terms of pure area, but we also need to consider planting rates as well. After all, these are all goals with specific end dates in mind, and we're going to have to plant specific numbers of trees to reach this. If you look down in kind of the bottom left, this kind of dark blue, this is a rate of planting we've achieved in the last 40 years or so. And this is compared to these different lines here, which is a rate of planting we would need to achieve to meet these different targets. And as you can see, other than perhaps this Committee on Climate Change low ambition target here, which is kind of a baseline business as usual one, these are all sort of dramatically higher than what we've managed to do, especially in the past sort of 10, 20 years or so. What we've been doing recently is really trying to focus on this idea of encouraging farmers and landowners to plant their lands by offering grants and through agri-environment schemes and whatnot. But as you can see, that hasn't been massively successful. If we go back a little bit further, we did actually manage to about double the amount of trees in the UK over the course of the 20th century. Around the mid-1900s, this was mainly done through expansions in state forestry. Basically, the Forestry Commission bought up agricultural land. Around this time, there was a bit of a depression in the prices of agricultural land, so they could go buy up all these vast tracts of kind of upland Scotland for cheap, essentially. But that's not the case today. Even in real terms, agricultural land's a lot more expensive than it was back then. Starting around 1980s, this kind of expansion of state forest stopped. We moved over to expansions in private forestry instead. In the 1980s, we saw, for example, tax incentives to encourage planting. But what this ended up doing, in fact, was causing quite a lot of environmental damage due to forestation in places like the Flow Country in Scotland. It became quite notorious, essentially due to a lot of kind of famous people using it as a tax avoidance scheme and wrecking these habitats along with it. So it's going to be difficult. Right, so like I said, this is basically kind of part one, step A of a wider project. We've now figured out, okay, where we can't plant the trees, so where could we do them instead? We now want to look at where we should put the trees. So we're now working on a bit of work, essentially looking to spatially optimize afforestation. If we're going to put a woodland somewhere, can we put it somewhere where it can help mitigate flood risks downstream? Can we put it somewhere where it can also be a useful recreational opportunity? And can we do it somewhere where it's going to be efficient for growing timber or something, for example? So that's what we're working on at the moment, and I'm hopefully going to be done with that soon. But if not, maybe I'll be coming to GISRUK for the third time in a row, and you can hear all about that next year. So yeah, thank you very much. If you want to get in contact, I've got my email address up there. Get in contact on Twitter instead. This is just a work account I've set up, so won't be posting any cat pictures, all that. Yeah, thank you very much. Really sorry for the technical difficulties before, but I hope it was worth the wait. Thank you.
Thank you very much, Tom. Very nice talk, and very well to salvage your technical problems. We're actually doing fine on time because it looks like our third speaker hasn't yet registered or isn't yet in the room. So it might be that we will not be able to listen to the third talk, which gives us, of course, a lot of an extra time to talk about questions or ask questions, and maybe give you also a little bit an issue. An opportunity to maybe to mention one or two things you might have skipped because of you thought you have to shorten the talk. I would like to kick off with a question from my side. Is did you consider hybrid farming schemes? Because you mentioned that farmers might be resistant to just stop being farmers and have to become foresters or maybe looking for another job. But there are schemes like agroforestry, for example, or maybe hybrid, more extensive forms of farming. Yeah. Did you look into these kind of options, or is this something in future works you might be, include in your views, in your research?
Yeah. So it's something we looked into to an extent, and as you say, it's something we want to look into more. It's quite interesting that kind of this idea of agroforestry. So what's it? Silvo-pastoral, silvo-arable practices. They haven't really taken off over in the UK as much as they have in other countries. And there's been different reasons for that suggested. I know there's been sort of discussion that some of that might be due to sort of the setup of our agri-environment schemes. So if you want to combine forestry and farming, you have to be really careful, because if you put a little bit too much forestry onto your land, then you'll start losing your agricultural subsidies and whatnot. So that's been suggested as one reason why it's not really taken off as much. And I guess also to an extent, especially here in the UK, a lot of our farming to an extent is agroforestry. If you think of the typical British landscape, the stereotypical idea of that is little bits of trees dotted around around green fields and all that. So perhaps to an extent we do consider it, but we don't just call it agroforestry. In terms of how that would affect the analysis, it's definitely something we want to look at. So a mixture of trees on farms, but also urban greening as well. So rather than just thinking about purely putting blobs of trees everywhere, could we say, okay, we want to plant 10% of fields in the UK, and then also increase urban trees by 15% or whatever. So do that to make it kind of more spread out and distributed rather than blobs of actual woodland. So it's definitely on our radar, but not something we quite had the time to do with this work.
Okay, a number of questions are coming now. Thanks for Paul for Holloway. Great talk. Have you thought about reconstructing agricultural land into productive versus unproductive agriculture?
Yeah, that's an interesting one. So go away. I'm in a more important meeting currently. Yeah, so I guess do you mean in terms of yields and whatnot? I guess to an extent, yeah, we only really considered the quality of the agricultural land itself with the ALC, but there's definitely a lot more you could do with that. I know one thing that I've had in my mind is that obviously displacing different types of agriculture will also have an impact on the carbon sequestration. If you replace cow pastures with forest, then that's going to take out comparatively more carbon from the system, or carbon dioxide equivalent, because of the polluting properties of animal agriculture, methane, and all that. So definitely thinking about exactly what we'd be looking to replace would be an important one. Yeah.
Okay, another question from Paul Brindley. Interesting talks. Could you all prioritize which areas geographically currently lack trees, but could facilitate them?
Yeah, definitely. That's something we definitely want to be looking at for the sort of the third part of this, essentially, where we're looking at where we should be putting them. So it's both in terms of where trees would offer ecosystem services, but also there's going to be a diminishing returns effect if you plant trees somewhere next to a city or whatever where there's not currently recreational green space, then that's going to be a really big benefit. If you then plant more and more trees, then the returns you get from that are going to be diminished because you've already got a good recreational woodland. Adding more to that isn't going to give you anything. So we sort of see it as kind of a bit of a bell curve where you increase the amount of woodland and it becomes really beneficial. But then when you've got loads of woodland already, then adding more to that isn't necessarily going to be useful. So the utility you get from that is going to go down as well. So yeah, definitely that's something we're going to be thinking about.
Yes. Johnny Huck is asking, excellent presentation. Will your optimization approach for planting locations be able to take account of spatial demographic inequalities that you identified? For example, balancing planting plants to minimizing inequality between north and south, for example.
Yeah, so it's definitely something we've got in mind. I think especially for the recreation side of things, there's thoughts that that's going to be more important if we offer recreational opportunities to more disadvantaged areas where you're having this recreational green space which would be free to access would be really beneficial. I know that's something that the Forestry Commission thinks about as well, so it's definitely something we're going to be looking at too. So it's the idea of green prescriptions, essentially, that this green space can give you all these benefits, and can we target that a little bit in terms of demographics? I'm not entirely sure if we're going to have time to do that, but it's definitely something I'm thinking about.
Yeah. David Kidd is asking, are you intending to consider variation in tree density and species growth rates? For example, open Scots pine versus closed oak forest, for example, especially in relation to rewilding.
Yeah, definitely, because the types of tree is going to have a really big impact on the services that it can provide. Like you said, a coniferous, a pine tree might be good for providing lots of timber, but might not necessarily be as good for biodiversity or recreational opportunities. Whereas doing a native kind of species, kind of old oak trees or whatever, might be really pleasant in terms of recreation, but pops won't be as productive in terms of timber, for example. So yeah, it's not just about where the trees are. It's about what they are. That's gonna be it's a really good point. It's gonna be important.
Next question coming from Gail. Considering the number of wildfires is increasing in the UK, have you considered tree species type to build resilience against wildfire risk?
No, that's really interesting. That's not something that I've thought about at all, to be honest. But that's a really good point. I guess when it's kind of grey and rainy like it is outside my window today, you don't think about wildfires in the UK, but they've been happening, haven't they? It's been all those kind of moorland fires as well. So that's really interesting. It's not something we thought about, but it's definitely going to be worth keeping in mind. Thank you.
Okay, thank you. These are a number of questions. I think we have time for one or two more. So if there are people are interested in asking a question, I think there's still the opportunity to type one into the chat box. While people are doing this or might doing this, I was just wondering from a GIS perspective, did you right now, as far as my understanding is, you had a more binary approach where you could suitable or not suitable, essentially 0 and 1. Did you look into optimization within the one areas between these suitable areas? So not just finding out where the best, where we could plant trees, but within these areas where we could plant trees, where might be the best. And when doing this, I think people touched upon this as well, just looking at maybe at something called, you might call sequestration optimization or something like this, when the goal is to sequester as much carbon as possible, might prefer to plant a tree in location A, where the climate and soil qualities enhancing growth, considering to other locations, for example.
Yeah, definitely. So yeah, so like you said, this is just kind of quite a simple binary yes or no approach. That's very much the kind of basis of this kind of third chapter we're working on now. There's two sides to it. First, we want to optimize to reduce cost. So rather than just saying yes or no, you can plant here, we want to reduce the cost. So whether that's then we want to optimize to reduce the number of constraints, or consider actual land costs, whatever. So that's one side, and then we want to do the other side, which is to optimize to maximize for benefits. So to try and get the most ecosystem services, and it's going to be thinking about
Nick Ham actually sorry to interrupt. Nick Ham is actually following up on this and said, do you have thoughts about how you could consider grades, levels of suitability here, how you could quantify uncertainty, and so on?
Yeah. So it's very much something we're thinking about right now. We've been looking at potential kind of tools or approaches we can do to consider this. So we're looking at a tool called Markdown at the moment, which is like an optimization algorithm, and it's we've got these constraints. Now can we turn these yes no layers into a more continuous sort of cost layer instead? How can you quantify uncertainty? That's going to be something we'll have to think about as well.